So here are the answers to resultant forces. Tick it off, see how you get on, and then if there's something that you're not quite sure of, go back to it again or go and ask your teacher about it. So we'll be looking at forces in motion now. Let's have a look at speed, velocity and acceleration. So what's speed then? Well, that's how fast something's going. And the unit is meters per second. It's always given in meters, not miles, per second, not per minute or per hour. It's meters per second. So speed is distance in meters divided by time. Just be careful, don't be caught out by the question. If it gives you different units, then you need to convert it. So there's the triangle, d over s times t. Now, if you're not sure how to remember that, then just remember, here's a little trick. S and T are next to each other in the alphabet. So S and T are next to each other in the triangle. If you cover up the one you're looking for, then the position of the other two tells you what to carry out. So if you're looking for distance, put your thumb over the D, and then it's S times T, speed times time. Now, you need to be able to use graphs. You need to be able to calculate the speed of an object from the gradient of the distance time graphed. And from the gradient, you can read off the distance covered and the time taken. So it's the same calculation, distance divided by time, but you have to read that information off a graph. You may not be given it in the question. So let's have a look at the graph. So this is a distance time graph, and you can use this to calculate the speed of an object. You can read off it the distance covered, and you can read off it the time taken, and then using those two values that you've got from the graph, you just carry out the d over t calculation. So the distance travelled is 30 metres. Follow the green line until it stops and read it off horizontally. Distance is 30 metres. Time taken, read down from the end of the graph downwards, time taken 500 seconds. So speed is distance divided by time, 30 metres divided by 500 seconds. Speed is 0.06 metres per second. Velocity. Now, velocity is an object's speed in a given direction, which means that if the velocity includes direction, then an object can continue going at the same speed, but if the direction changes, then it's got a different velocity. And it's given in meters per second in a given direction. So this means that if an object is going round in circles, it may have a constant speed, but its velocity is constantly changing because it's constantly changing direction. Now, acceleration, this is the change in an object's velocity over time. And you can calculate it using this equation. A, for acceleration, is final velocity minus initial velocity divided by the time taken for the change in velocity. So A equals V minus U, final velocity minus initial velocity, divided by time. Now, just remember, time's going to be in seconds. So here's an example of that calculation. An object accelerates from 10 meters per second to 13 meters per second over a time of 5 seconds. Calculate its acceleration. So let's put it into the equation then. The final velocity is 13 meters per second, so put 13 in first. The initial velocity is 10 meters per second, so put the 10 in after that, so it's 13 minus 10, divided by the time taken for the change, divided by 5. So the acceleration is 0.6 meters per second squared. Acceleration is in meters per second squared. So let's have a look at this graph then. Now, the gradient of a velocity time graph represents acceleration. So we need the velocity and we need the time taken. That will tell us the acceleration. So the velocity, read it off horizontally from the y-axis. The velocity you can see is 30 meters per second. Read off the time taken, that's vertically from the x-axis. Time taken is 70 seconds. So the acceleration is 30 divided by 70, which is 0.43 meters per second squared. Right, so if you're doing higher tier, then you need to practice some calculations. So you need to be able to calculate speed from distance time graphs. So without cheating or looking at the answers, see if you can work out the speed of the green and the blue lines. So read off the graph the distance, read off the graph the time, and then calculate speed as distance divided by time. Pause the video while you do this. So you can read off the graph that for the green line, the speed is distance divided by time, so that's 120 meters divided by 300 seconds, that's 0.4 meters per second. And the blue line, speed is distance divided by time, the distance is 110 meters divided by 600 seconds, which is 0.18 meters per second. Now you'll notice that I've given these answers to two significant figures. This is the convention. It's been rounded off to two numbers, not including leading zeros. Now you're often asked in these physics exams to give your answers to two significant figures, and you will lose a mark if you don't follow this instruction. So if it tells you to give it to 2SF, then you must do so. A dot or an asterisk to show recurring numbers is not acceptable in this case. But what's happening with the pink line then? If you work out the speed for the first part of the graph, it's 40 meters divided by 300 seconds, so the speed is 0.13 meters per second for the first part of the graph. But after 300 seconds, the distance doesn't increase. So what is this object doing then? It's actually stationary, isn't it? It's stopped, it's pulled up. Time has carried on, but the distance hasn't changed, so that vehicle has stopped. What about line 4 then? Distance is increasing at an increasing rate. What's this object doing? It's a curved line. Well, this object's accelerating, isn't it? The distance is increasing at an increasing rate. That's acceleration.